Okay, great. Thanks, Sarah. We are doing well on time, so we could take one or two questions if there are any question askers in the audience for Sarah. Yeah. Oh, sorry. Well, can we go to bed first since I think, or either way is fine.
Oh, okay. So I was curious about uncertainties in the orbital parameters and how those carry forward into the results of the orbit integration. If you're going to see if something's resonant for half a million years, the uncertainties need to be really small in the orbits. What fraction uh, of minor planets have such good orbits? Is that something that is just as important a contribution of Rubin?
Yeah, absolutely. So when we did these numerical simulations, in particular for the objects that are near Jupiter, we absolutely wanted to take into account their orbital uncertainties. And so we cloned all 12,000 objects 1,000 times and integrated 1,000 clones for every single object. And we used the results from all 1,000 clones for each object into our classification. So there's a few points on here that are orange. These are things that we had to give an insecure classification because their orbital uncertainties weren't small enough to give us confident results of whether they actually are resonant, temporarily resonant, or not resonant. So yes, the orbital uncertainties are very important when you're trying to figure out the dynamical nature of these objects. Yeah, thanks for the question.
Thank you. That was a super clear talk about the solar system, and it's really hard to explain the solar system clearly, actually. Early on, when you were showing like the different structures that you identified, you had the block plot with the main belt asteroids. There's a lot of substructure in the main belt asteroids. So I was wondering, how much of the identification of individual families and structures is a data-driven process, where you look for substructure in the data? How much of it is driven from like the theory and dynamical knowledge that there's going to be orbits and resonances, etc.?
Yeah, so I think originally these different groupings that we came up with were based on the observations. And so making these type of plots and seeing that there's clear structure in the data itself. And then I had several slides, particularly on the main belt and the near Earth objects, which I didn't have time to actually include. But looking at that structure then helped us realize, because you see these clear gaps here in the main belt, that there are more resonances that are located here. And we then realize that those resonances are moving objects from the main belt up into the near Earth population. And so there's a dynamical nature that started coming out of looking at the data originally. And some of the classifications that we have now have evolved as we've kind of coupled the dynamical part to it with the observational part, if that answers your question. I think in what we know so far, there might still be some space for that, but things like LSST or these other large surveys, as they're going to find many, many more objects in the solar system, increasing our inventory of small bodies by a factor of 5 to 6, that with that amount of data, there could absolutely be things that we don't know about now that we'll need to be able to search through the data in this dynamical type of way to be able to figure out if there's a lot more structure that we just can't see yet. So yes, absolutely.
Okay, so let's thank Sarah again.